Hi everyone, so today I will be doing chemistry paper 3 Johor 2025 trial. So let's learn how to do amali together with me. So this is all of the apparatus and materials, so just take everything during the exam. We're not going to do that for this, we're just going to skip that. So let's read the procedure. Make sure to really read the procedure and always go back to the procedure as you're answering your question. Always try to not just do stuff theoretically, which a lot of students, including myself, always try to do experiments theoretically based on what we learn instead of reading the procedure, which is a very crucial step, because I mean you can be knowledgeable about the chapter that they're going to be experimenting us with, but that's theoretical. This is how we apply that concept, and it might not exactly be what we learn. So let's read. Cation is a positively charged ion that is present in an aqueous salt solution and can be identified by qualitative analysis. Okay, so you're required to carry out an experiment to identify cation in salt solutions. Okay, let us highlight what is important. Okay, so identify cation in salt solutions. So we already know that this is going to be Form 4 Chapter 6 based on what they're asking us to identify, which is cations. So the first step is to dissolve solid P nitrate with 10 cm3 distilled water in a beaker. Okay, so we can know that the P will be the manipulated variable because at the end it says repeat steps 1 until 5 by replacing solid P nitrate with solid Q nitrate. So next step is pour 2 cm3 P nitrate solution into a test tube labeled X. Add a few drops, okay, so ammonia solution. Add a few drops of 1.0 mol negative Q ammonia solution to test tube X until excess. So this is added until excess ammonia solution while shaking it. So this one, it requires us to memorize each cation identification. So if you don't memorize that, then it's going to be very difficult for you to answer this kind of amali. So make sure to really master that part. Now pour 2 cm3 of P nitrate solution into another test tube labeled Y. Okay, pour 2 cm3 of region A. So we have region A into test tube Y. And repeat step 1 until 5 by replacing solid P nitrate with solid Q nitrate. Okay, so this is the kind of experiment that is pretty theoretical. I mean, I don't have solid P or whatever, so I'm just gonna write down the results based on the schema, because I mean, I don't know what solid P contains. I can't tell because I can't do the experiment in front of me. So usually, I mean mostly and pretty frequently, okay, you know, let's just say memang a manipulated variable will always be the first part of the table. So we already know that this is our MV. So solid test, solution test, MV, so P nitrate and Q nitrate, so type of solution. Okay. Next we have ammonia solution, which is to test what kind of cation is it, and then we have region A, which is unknown. Okay. Now let's see the results. Then based on the results, we can already assume what cation is it if you memorize. So P nitrate, white precipitate form, soluble in excess ammonia solutions. There's only one, which is zinc 2+ ion. So white ammonia solution. So I'm gonna say that this is gonna be zinc nitrate. Zinc nitrate. Okay, so region A, what happens? No change. Okay. Okay, so this must be potassium iodide because here white precipitate form insoluble in excess ammonia solution. So this is Pb2+. So this is PbNO32. So remember the white precipitate that is soluble in excess sodium hydroxide, there's 3. I like to remember ZAP. So soluble in excess, NaOH is ZAP. So I like to say Z is special because my name starts with Z. So this is how I remember that this is zinc is the only one that dissolves to form colorless solution in excess ammonia. Okay, this is not the full I yet. For A and P, it doesn't. Okay, it only forms white precipitate. So from that, I know if it's soluble, then it's definitely zinc, and if it's not soluble, it's either aluminium or Pb2+. But because yellow precipitate is formed, I can assure you that this is Pb2+. So white precipitate form insoluble in excess ammonia solution. Okay, state inference. Okay, so inference for the observation of cation test for P nitrate and nitrate solution by stating the cation present. Okay, so inference for chemistry and biology, it's usually the reason on why that happens. So they want us to state the cation present, so that's going to be zinc 2+ and Pb2+. Is that correct? Zinc 2+ present and Pb2+ present. Yep. Zinc 2+ ion present. Pb2+ ion present. Okay, just to be safe, because they ask us the requirement for the question, which is they want us to, by stating the cation present, so they want us to say that this is present. So don't just say zinc 2 plus ion or Pb2 plus ion. Make sure to take back what the question wants and say present, just to be safe, because you don't want to make these silly mistakes. And even in this schema, it mentions present, so yeah. Based on the test done by using region A, state the operational definition for insoluble salt. So operational definition for chemistry, we have to mention first what is done. Second, what is observed. So this is very basic, and we really have to, oh my gosh, why am I stuttering? We really have to follow this format. So let's say what is done in this experiment. So this one, no change. So I'm just going to look at PbNO32. So what is done is when we add region A, when we add Q nitrate to region A, and then what is observed, a yellow precipitate is formed. So this is basically an insoluble salt. So we can conclude that when Q nitrate is added into region A, yellow precipitate is formed. Or this is specific, but I'm not sure if they want it to be general, but we'll see what to do with observe. Insoluble salt is a substance that forms yellow precipitate when region A is added into Q nitrate salt solution. Okay. So insoluble salt is a substance that form. Wait, this is what observed and what is done. Ni kot terbalik. So we're gonna say this first and then this second, because that's the observation. So insoluble salt is a substance when reagent A is added into Q nitrate salt solution, a yellow precipitate is formed. Okay, next. So write a balanced chemical equation for the heating of solid P nitrate. Solid P nitrate. So this is solid P nitrate. Damp blue litmus paper turns red. Brown gas form. So this is definitely this is definitely NO2, nitrogen dioxide. Damp blue litmus paper turns red. And it also contains acidic properties. Glowing wooden splinter lights up. This is O2. So the only type of cation test where there's two gases formed is nitrate salt. And it already mentioned solid P nitrate. So we already know this is Zn. NO32. So there should be no problem in writing a balanced chemical equation, which is, again, you have to memorize the cation test for the heating of solid P nitrate. So
to anyone that struggles writing balancing chemical equation, or for those that think they take too much time in balancing chemical equations, the simplest method is to make everything an even number. And how to do that? Times everything with 2. Because I find it so easy to balance when everything is even, instead of dealing with difficult numbers that perhaps you have to balance oxygen when it's an odd number and then the other side is going to be even. So just might as well make everything even and save your life. And other than that, you make sure if there's CHO present, always to balance C first, H first, and then oxygen. And I think that's about it.
plus O2. Yep, I'm right. Now name brown gas. Oh my gosh, name brown gas form when solid P nitrate is heated. It's nitrogen dioxide. It said name. Okay, so do not write the chemical formula. Name brown gas. The observation. Okay, for prediction, for chemistry, if it's not theoretical, we must always give the value. Don't say increases, decreases. We have to always state what is the value. So predict the observation when P carbonate powder is dissolved in water. Okay, this is something that's does not require value lah. Macam if they ask us for thermochemistry and they say, oh, what happens when sulfuric acid is replaced by hydrochloric acid to the temperature change? So we have to either mention double or we give the value of the temperature change when doubled. Tapi this one no need lah. Predict the observation when P carbonate powder is dissolved in distilled water. So they're trying to say ZnNO32 carbonate powder. ZnCO2 Zn zinc carbonate is dissolved in distilled water. Explain your answer. It forms a white precipitate. Did I spell it right? Yeah. Bicarbonate is insoluble in distilled water. No change. I see. Bicarbonate is insoluble in distilled water. So all carbonate salts are insoluble except for ions, which is sodium, ammonium, and potassium. Or you can say no change. But usually for prediction, I always love to give more than one. So else I would say something random like, oh, white precipitate insoluble. So maybe one of them would be right and it would be accepted. Reason: bicarbonate is insoluble salt. Although I do not know what the color of zinc carbonate is. Classify the following salts into soluble salts and insoluble salts. Okay, so I'm not going to do a table. But when you want to classify, make sure to do table. Okay, here you have to memorize the soluble and insoluble salts. Aluminium sulfate. Sulfate, I like to remember for sulfate, it's Persatuan Bahasa Cina. So sulfate salts are insoluble, it's Pb. Persatuan Bahasa, barium, Cina, calcium. Nitrate, all nitrate salts are soluble. So I'm just going to label this soluble. This is also soluble. All carbonates salts are insoluble, so this is insoluble. Chloride, I like to remember Persatuan Agama Hindu, so this is insoluble.
This is what I meant just now by the insoluble salt for chloride, which is Persatuan Agama Hindu.